Hello everybody, and welcome back to another video. In this video, we will be covering basis. So to get started with this idea, let's look at this vector right here, 2, 2. Now we write this out as 2, 2 because we go 2 units this way and 1 unit up, and that leads to our answer. However, we should look at this as going in the x direction 2 times and then going up 2 times, as this column represents the number of times you use a vector in this direction, also denoted as I hat typically, and this represents the amount of times you go upwards, also denoted as j hat typically. So this vector could be represented by 2i plus 2j, as I and j are the unit vectors. So now, what would happen if we didn't use these two vectors? Because these are just two arbitrary vectors. We could use any vectors to describe another vector, right? So let's assume we use these two vectors down here to describe this big vector, vector x. So what we want to do is set this vector, which I'm going to write in column form, equal to a constant, which I will call a, times this vector representing this, so 2, 2, then adding that to another vector, which I will denote this part with b, of 1 and 3. Now, do you see how this is similar to the I hat, j hat notation? These just represent the I hat and j hats. However, we are now using different vectors. Now, the value of this a and b determines the coordinates of this vector. So our answer is going to be in the form a comma b. Now all we need to do is solve. So we have this vector is equal to, you multiply the a to both, so you get 2a plus b, 3b. And now all these columns must be equal to each other. Or these columns must be equal. So 6 must be equal to 2a plus b, and 10 must be equal to 2a plus 3b. So this is just a standard system of equations. So in order to start solving this, we will subtract 2a from both sides. We get 6 minus 2a is equal to b. And now plugging that b value into this equation right here, we get that 10 is equal to 2a plus 3 times 6 is 18, minus 3 times 2 is 6a. These two go to negative 4a, and we move it to the other side to make it positive, and then we subtract 10 from both sides and get 4a is equal to 8, so a is equal to 2. Oops. A is equal to 2. Now we just plug that in to solve for b. So 6 minus a is equal to b. 6 minus 4 is equal to b. So b must also be equal to 2. So the coordinates of this vector, so vector x is equal to 2, 2 with the basis of 2, 2 and 1, 3. Now we got the answer. However, I'm going to show you how to visualize what we just did. So since we have 2 of each of these vectors, let's duplicate them. And now let's put them tail to tail, tip to tail. So this represents vector addition. So I just put that one right there. Now I'm adding this vector right here. Now I'm adding this vector right here also. And we get this right here, which although it is not exactly equal to, it technically is, as I just made mistakes with my vectors. Some of them may have been a little bit too long. I may have placed them in the wrong spots, but these are at the same spot mathematically, which makes sense because these vector x is still the same vector. We just used a different system. We used coordinate. So I hope you all enjoyed the video. Please like and subscribe, and thank you for watching.